manufacturing is already transforming not only the way we work, but the way we consume, and indeed the way that we live. That is the central thesis of our next keynote, entitled The Human Factor. And here to deliver it is a renowned international expert on the challenges and opportunities associated with a new production paradigm. It's a great honor to have with us Krystyn Van Vliet. She's Professor of Materials Science and Engineering at the Massachusetts Institute of Technology, MIT, and Director of Manufacturing Innovation with the MIT Innovation Initiative. Welcome.
Thank you. Thank you very much. It's a pleasure to be here in Berlin with you and to hear the remarks from the minister. It's also great to be here working with the World Economic Forum on the future of production. So I'm eager to share our thoughts with this audience. So this human factor is very interesting and very challenging. And what we're going to do is look at this from how it affects the individual at a few different levels. One is the citizen. We are all citizens of our own countries and also the world. The second is the coworkers. So when you're doing your work, how does digitalization of manufacturing affect the way that you work? And then finally, the companies. And so taking a look at this from three different pieces of our lives and how digitalization affects this. So this is a phone. It's my phone. It's an iPhone. And I use this a lot. Many of you are taking pictures of my iPhone with your iPhone right now, right? And I use this phone most of the time where I live and work at MIT on the East Coast of the US. And many of the folks who designed the components of that iPhone are actually from MIT. In fact, the largest employer of our mechanical engineering undergraduates is the company that made that phone, Apple. But it wasn't designed at MIT. In fact, it was designed here in Cupertino, California, at a very dynamic place to work called Apple. And it wasn't manufactured in California. It was manufactured in Shenzhen in southern China. Right? So there's a great bit of connectivity and a lot of thinking about, is this the way that digitalization of manufacturing will proceed? Ideas in one place, design in another, manufacturing in a third. And even that is incomplete because it doesn't tell you what you're going to do with that iPhone when you're done using it, right? And how does it make it back into the circular economy? So there are lots of challenges here in that picture. And the thinking is not new. In fact, it's always taken connections between the idea, the initial innovation, and the production, right? The industrial revolutions of previous years have been built on connecting the ideas to innovation and making it more efficient to do so. And the way that we connect that is increasingly through using human hands in a new way to create new processes that create new products. And in order to do that, we also need these production ecosystems. And these production ecosystems will increasingly, as we understand in Industry 4.0, use the fact that robotics, machines, information, data are part of the way that we're manufacturing. So when we do that, we can do things like not only make Ford motor vehicles the way that we used to, but create new companies such as Local Motors that can 3D print cars. Right? So those tipping points that are discussed in Industry 4.0, several of them are already here. And the question is, how does this affect us as individuals? If we take that example a little bit more technically, this is an example of a 3D printed component, a toy, a sculpture. Right? And this is the way that many of us have interfaced with 3D printing most recently. But this idea of additive manufacturing, this new way of making components and prototyping, that is not new. These ideas came before I was born. Many of these ideas and the folks who developed them at the lab and company concept are now retired. Right? But it's making it onto full-scale production now. So how did we get from focused ideas about fluid viscosity and polymer processing and machine control to then the point where we can actually print a replica of a Shelby Cobra in a period of 12 weeks' time from design to manufacturing? That's a challenge, and that's a challenge that's been met, as I'll discuss with you, largely through public-private partnerships to speed that innovation to market. This is a picture of our former Secretary of Energy, Ernie Moniz, taking a spin in this Shelby Cobra car that, again, looks like it's made of metal, but is in fact a 3D printed polymer composite. And there are companies that can take not just that one replica that can be made in 12 weeks, but now companies that can produce for you a customized car with customized components through similar technologies. That's a huge burst of innovation. It also, as the name of this particular company evokes, shifts the way that we're producing things to more distributed manufacturing, and the digitalization is enabling that so that we don't have one company that makes and distributes the cars from a single factory, but many, many factories distributed throughout the country or the region or the world. So what does this mean? All of these shifts and the seeming rapidity of these shifts to these different stakeholders. So if we look at the citizen, this example of the iPhone and the 3D printing and carrying that through, this means a few things. One is a huge onslaught of information, right? So the ease of accessing data and information, and the ability to actually sift through that available information as a citizen is impressive and increasingly challenging, as was mentioned. There's also an increase in your life productivity. So for example, when you want to call a cab, you can do so from your cell phone. I do this to find the cheapest rates and the cheapest routes, right? So this convenience can make my work life as a citizen more productive and my out-of-work life much more productive. You can also multitask in a way that you couldn't because of this connectivity. So for example, while I'm working, I can also be vacuuming my own house with a robot. And I do this, and I love it. And that company, again, who made this robot, this iRobot company, again, the ideas, the initial company, the prototypes, Boston, Massachusetts, the current large-scale production in another country. So that will always be a shift that is part of innovative production. And as we'll discuss, that's not a focus on the necessity to reshore or protect technologies, but to figure out how to deal with these shifts in a productive way. Now, what I don't do with that vacuum, but I could, is use that same phone I used to call a taxi to program it to, from here, right? I could be vacuuming my house right now. I don't do that because of cybersecurity concerns, right? And so this, as a citizen, is one of the things that we also need to weigh. There's also increased job flexibility, which, as this photograph indicates, is not necessarily a good thing for all parties concerned, right? So the work-life balance can be more challenging because you can be right now checking on your production lines and your logistics while you're listening to my talk, while you're on the plane, and while you're supposed to be on vacation with your family, right? So there's that challenge as a citizen. There's also this challenge in terms of how do we better connect with digital components in a way that requires us to not just have skills, but to constantly reskill as we develop those technologies. And then finally, the tension that this sets off, right? So the tension between man and machine when you have not just a loss of jobs, but a shift in the skills of the jobs that are required. Okay, so that tension between how do we digitalize and do so in a comfortable way and still use the productivity that's available to the citizen is a challenging concern in many families. Now, the benefits of this vary from region to region. One of the focuses in Asia in particular is in smart cities. And so this interconnectedness of components enabled through new kinds of manufacturing is impressive and comes with challenges and risks. The stress that this puts on the environment and the way that we actually use resources for the productivity is another way that it affects the citizens. So here you see a hydroelectricity power plant, very important and interesting for manufacturing, and yet the water that's diverted in order to create this carbon-free fuel, right, also has serious consequences for the people that live in that region. Here's an example of an open pit mine used to get many of the materials in my cell phone. This open pit is in the US. And it doesn't look that different from the open pits that are in China and produce much more of this material, nor does it look that much different from the open pit in Peru that produces a lot of the copper and zinc that are in that phone you're using right now. Okay? So these challenges to the environment do affect the citizen. They're often less visible, and the answers for how to deal with that are increasingly relying on how we digitize the end life of these products that we're producing. Now, to the coworker, there's also quite a few challenges. So one is that, again, not reshoring but reskilling becomes a very important part of how we think about working with our peers, recruiting new people to the industry. And so this focus on internships, apprenticeships, and constantly being able to adapt our skill set becomes important. This will include increased use of robotics, not only in the training and in the production, but in the disassembly of components and the design for manufacturing. And that requires a set of skills that was not taught at university when I was in school, and still is a challenge for us to incorporate into the educations of the engineers, technicians, trade workers that you'll be hiring over the next few years. So how do we think about that retraining? On the other hand, the coworker now has an incredible amount of flexibility in the customization of the products that he or she is producing, right? This can mean not only phones, but new kinds of architecture, new kinds of materials, new kinds of robotics, new kinds of electronics. So that ability to be creative in the way that you're producing is very empowering, is intellectually stimulating, and it's part of what's moving manufacturing from a conception of dirty and dangerous careers to very intellectually and financially rewarding careers potentially. But there's also some negative aspects to the coworker. One of these negative aspects you see here is more individual work. So here you see examples of two people who are interfacing, one with a computer screen and one with a robot, and not another person. Right? And still, that human interaction in the workplace is important, and it's not replaced by WebEx meetings. Right? So we know this through our own experiences, why you're gathered here in person instead of just watching this on your computer screen, in terms of the attention, the interactions, the ability to form relationships that make change within a company or within a society much easier. I understand this in the way that I work with colleagues. When we had a big snowstorm earlier this week in the US, it delayed my arrival here, but it didn't keep me from having class because I could connect online with my students. However, it wasn't nearly the same kind of interaction as we were in the room. Right? Many things get lost in translation when the co-workers are operating only through digital interfaces, and that's something that we all know intuitively, but we are not necessarily building our production processes around that importance of the human-human interface as well as the human-machine interface. And then there's the issue to the coworker of security. So when you are digitizing your manufacturing and digitizing your reskilling of your workers and digitizing the products that you in fact are making so that you can design at one place and send them to another place for prototyping or production, that issue again of physical cybersecurity comes up, not in whether to connect your robotic vacuum through the internet to your cell phone, but in whether to connect the processes that you as a coworker share with another coworker, or you share with another company with whom you're collaborating. And so this increasingly is a challenge. To illustrate that, I work at a very high-tech university. It's a privilege to work there, and all of my machines at MIT are disconnected from the World Wide Web. Right, for physical security reasons. There are also many companies that now operate with an intranet, and if they're a production company, do not have those key assets connected to the internet. And so that's a challenge in terms of moving forward, and moving forward collaboratively. So then if we think about the company as that third type of our lives, right, that third group to consider, there is this advantage of distributed manufacturing and production, more creativity, more customization, which can be an asset in terms of the products that we're putting out, and also in terms of the profits that we're generating, right? There is also increasingly the opportunity to automate those products, and we have discussed the pressure and the technologies that that can require, but that only happens if and when it makes sense in terms of the life cycle of the product. So you see images like this with fully automated production lines, and those can be observed when the production life cycle is sufficiently long and sufficiently standardized. But in many cases, including this cell phone, many parts of the production are not fully automated, and those companies have decided it does not make sense to fully automate them, in part because that production life cycle is so short. Right? If you're changing your production requirements and capabilities and materials and designs. And this is a period that captures many of the digitized products that are being made right now because of the rapid life cycle. But in the cases where you will have more and more automated production, that human-machine interface and the role of apprenticeships and internships in creating the whole value chain of workers will be increasingly important, will be part of the way that we educate, and the increased use of data. So many people, all the way from the beginning to the end of the value chain, will get more comfortable with using data, which again, at the company level, brings up this issue of physical cybersecurity, one that everyone knows is important and few want to spend their own resources on, right? For example, this disconnecting from the web for key assets. Part of this is data interoperability and standards, agreements among companies and countries, and new technologies to be able to share data and protect what is proprietary and competitive while sharing what is enabling to others. And this is a challenge that companies need help addressing, that it won't be met by any one company. People do as little as they can to protect their most important assets, and that's not an easy way to move forward quickly. So if we look at this in a graph, as an engineer, it's always great to be quantitative and graph. We have actually seen these features laid out in the following way in the challenges. If we put on the vertical axis a dollar sign, this can be profit and loss, and this can be investment. And if we put on the horizontal axis the production scale, right? You're connecting from the ideas, the initial ideas, to then the final commercial product that is going to turn a profit, not just once, but many times. So in the middle is this so-called valley of death, right? So how do we get over that valley of death where you have the idea, you want the profitable production, the digitized manufacturing and the more traditional manufacturing requires a lot of capital-intensive investment, prototyping, and de-risking of new technologies, especially challenging for small and medium enterprises that are not capital-rich. And so many countries and regions have been trying to create bridges, and many of these bridges are in the form of public-private partnerships. This happens very extraordinarily in Germany, and in the US and many other countries. If we first take a look at Germany, the Fraunhofers have been a really key jewel in the German system in terms of developing new technologies and also developing new workforces. There's 60 of them in the country. Those of you who are from here certainly know that. And they're very interesting investments between the federal government, the state government, and also requiring a third of the funds to be raised from industry. So they are of value to companies, and that's part of their mission space. And they've been seen as so valuable, not just in terms of building companies, including spinning off new ones from the Fraunhofers, but training the next generation of workers through apprenticeships with and for industry, that they've been expanded worldwide. And so there are Fraunhofers now in the US, in China, in Japan, as well as throughout Germany and other parts of the EU. So this is one example of a public-private partnership. There's a more recent example, in many ways inspired by and modeled by parts of the Fraunhofers that can also work in the US, and that's called Manufacturing USA. So this is a network of institutes, 14 right now, that were initiated during the previous administration, and each one is focused on a public-private partnership between industry, academia, and the federal government and local regional economic development authorities. So there's 14, each on a different topic. What is interesting about these in terms of their role in de-risking specific technologies and reskilling the next workforce is the way that they can actually work together as a network. So I'll show you just a subset, an example of how this could work. You could actually have digital design and manufacturing of a component that is then made through additive manufacturing, through new kinds of metal inks that are developed at one institute, integrated into composites that require lower amounts of energy and resources to produce at another institute, more further automated for small batch and large batch production through robotics developed specifically for manufacturing, and then at the end of life be able to take that composite material apart and use the resources over again for that or another function. So it's that networking between different parts of the digitalized manufacturing that make this impressive. As another example, the semiconductor industry grew very robustly in the US in the 80s, has largely offshored over recent decades, and so rather than trying to reshore that kind of manufacturing, which is done very well in other countries, can we move towards the next technology in our country? And so the focus here is integrating photonics into semiconductor manufacturing in one institute, integrating that with lower power electronics, so wide bandgap semiconductors in another, making that printable on a flexible surface so I can wrap it around other objects to open up the product space, drawing that into fibers, so now I can use that material that has photonic and electronic components in fibers and textiles for smart wearables, and then automating that process through the use of robotics that use the human and the robot together in new ways. Okay, so these kinds of examples would not be possible without public-private partnerships between the companies, the government, academia, and civil society members and nonprofits. Part of what makes these so interesting and important is the fact that companies that typically competed with one another are collaborating on the parts that are of greatest interest to them and don't affect their ability to create profitable project after it leaves the institute. So as a couple of visual examples, the American Institute for Manufacturing Integrated Photonics, AIM Photonics, is only about a year old, so these are much less mature in their operation than the Fraunhofers. But we've got thought leader experts. Here I'm showing you two professors from MIT who are helping to design some of these components. But then the people who need to be skilled and do that operation include people who have to work in bunny suits and outside bunny suits, so large part of the value chain. And then people who are on the manufacturing line learning how to use these tools to make their own production processes better. As the last example, I'll show you these funny-looking objects. These are so-called boules. These are polymers, but the materials inside the polymers in the center of those cylinders are going to be drawn out into fibers. And this was an approach developed also at MIT to make fibers into semiconductor devices and add new functionality to the fibers that are used so that you can then weave them into new and flexible components and have not only smart wearables and wrappables, but many different kinds of, for example, smart filtration membranes. So a very wide design space because the process is the product, and then you bring the workforce along with the reskilling. And that institute in the US is called Advanced Functional Fabrics of America, AFOA. But of course, the idea is worldwide impact. So to have that worldwide impact, one of the challenges in many of our countries is attracting the best talent to digitalization of manufacturing and to the manufacturing and production enterprise in general. This poster in the US is from just last year, so it's not a 1950s poster as the fonts suggest. But unlike Germany, where manufacturing is seen as a high-value, respected, rewarding, and stable career, we're still making inroads in the US to have families, citizens, understand that this is a great opportunity where the reshoring is not the focus, but the reskilling is, and you're constantly reskilling as technology develops. This includes diversifying the workforce, not only in terms of gender, but in terms of regions throughout the world, which creates its own challenges. and integrating the use of machines and interactions with machines. So the challenge of doing that is also bringing back this focus on physical cybersecurity, right? So having this production integrity. But as we do this together, region by region, with groups of companies and groups of countries, this focus on digitalization of manufacturing creates tremendous opportunities for the citizen, for the coworker, for the company, and also for the world. And that's the world that I and others are looking to build. Thank you.